All right, hello everyone. Welcome to the R&D live stream. Um, Today I will be going over this kind of like blog post that I made, which is called Cheers, a computational exploration of alcoholic beverages. And is kind of like showcasing some of the new data that we've added in our food offerings. So I think up to now we have had kind of a gap in the available sort of like alcoholic beverages data that we had. And we hopefully filled that gap. So we wanted to show everybody like the cool stuff that you can do with it. And then I'm also going to try to go over a little bit of how to use food, very sort of basic the way food works in Wolfram language for you guys, because I know it's not necessarily that straightforward. So yeah, I think I'll get started. Let me know like if you have any questions, put it in the chat for whatever stream platform that you're on, and I'll try to answer those like as I'm going, and then I'll obviously have time for questions afterwards. I think this will be pretty short, so please feel free to ask anything related to food, how food works, how alcoholic beverages works, how anything works, and I'll do my best to answer them. Okay, so I'll get started. So like I said, this blog post is sort of like I adapted this to do this talk for you guys. I'm not going to go through sort of like every single piece of text that's on here, but feel free to go read it. You can also get the notebook from this post and like evaluate the code alongside me if you like. But I'll also be doing that here for you guys to see. So let me just do a really quick basic on how food works. So I think food entities are kind of complicated. So when you, for example, in Wolfram language, if you're working with like city entities or country entities, something like that, usually the format for typing those in is kind of like entity. And then in the two arguments, you can say like city and then whatever city that you have. And then sometimes there's a little bit more that goes into it. I think food entities are a little bit more complicated because the way that we sort of represent a food that I like to say is kind of like the idea of a food. So we kind of we talk about it as like if you go to the store and you buy like a specific apple and it's this branded apple that you bought from a specific store, that's like a specific food. And that's sort of like, we call them like explicit food entities because they're explicitly specified like what they are. And then we also work with something called sort of like implicit food entities, which is these type of big yellow box things, which are kind of like the idea of like all apples that you could get from a store. And you can have it like as complicated or as simple an entity as you want. So I'll just show you guys. For me, the easiest way to get an implicit entity out is to use natural language input. So if I, for example, was looking for refried beans, I could do this kind of thing and then get out this nice yellow box that represents sort of like the idea of refried beans. So this isn't like any specific type of food. Like this is not your branded refried beans. This is just like the idea of beans that are refried. And then you can also get access to all of the foods that sort of live inside of this box of all beans that are refried. And you can use entity lists to get this, although a lot of our foods are huge and have a bunch of foods inside, so I'm probably not going to get the full list out for you guys, but I will get 10 of them. And so these are what I was talking about before in terms of like explicit foods. So these have more of a classic entity formulation. And this would be sort of like your branded specific refried beans. So here we have like San Marcos, M. Sanmar, refried black beans. It's probably, that's like some branding here. Rosarita, I know, is a brand. So this is where you can get sort of like more specific in terms of what foods you're actually talking about. And then here we also have like a few little comments on like what the source of the food is. So like we get a lot of our food entities and nutritional information from the USDA database. And that'll be reflected here on all of these foods. You can see they all have USDA branded on them. Some of them have some other sources on them too. So we try to include everything just so that you know what you're getting. So each food that's an explicit food will have some nutrition attached to it. But the reason that we work with this implicit food construction is that we get to give you sort of like the most robust average answer for anything that you would want to ask. So you can put an explicit food into like an entity value call, or you could put an implicit one, and you can get sort of information out either way. I would recommend to work with implicit foods because, like I said, they're very robust. They have sort of like the average for like every single food that you could get that we have sort of within this box. And so in my view, that makes it more likely to be an accurate answer for whatever you're asking for. So I can give you just a little example of that. So you can put the implicit food into an entity value call. We have a lot of properties in food, so sometimes I need to sort of like just get a list of them out, which you can do by going to food, and then you can do properties, obviously capitalized, and you can see that we have so many different properties that you can get for your foods. And then something else I like to do is just sort of like narrow it down because obviously like this is really hard to look at. So sometimes I'll just do like I'm looking at my notes here to remember how to do this. So why are things not getting capitalized for me today? Here, I'll explain a little bit too. So the way that these look outside of the yellow box is that the second argument is like the name of the property. So I'll do like a string search basically on the second piece of that little property thing. So string contains Q last of hash, and then I want something that has calories in it. So all the properties that have the word calories in them. I'm gonna ignore case because I didn't capitalize calories. And then let's see if this works. Yeah, so now we get a nice little offering of all the properties that you could get for a food that have the word calories in. You might get more if you don't pluralize it. Yeah, there we go. So you can get all these different things out. So if I were to do, if I were to want to know like the calories from fat from refried beans, I could use this yellow box. I could go entity value, put that guy in there, and then ask for relative fat calorie content, doing a lot of copy pasting so the yellow boxes are pretty, and then hopefully that'll give us something cool. Another thing you can do is obviously put more than one property in, get sort of like everything that you could want. We have a lot of really cool properties available for food. Yeah, so we have this relative fat calorie content in calories per gram. And so like if you were to ask for, let's see if this will work, 100 grams of refried beans, you'll get something like an entity instance, which will be like, here's 100 grams of this food. And you can put that in entity value as well. And we can ask for, I think there's probably like a total calorie content, absolute calorie content in here, but I am not going to look for it. But for example, if you wanted to just say like, okay, how many calories are in 100 grams of refried beans, you could just multiply this by 100 because you have the relative value here. But yeah, there's plenty of really cool stuff that you can do with food. Like I said, there's so many properties that I can't even keep track of them, even though I am looking at this stuff all day. So I really encourage like exploration and trying to find sort of like obscure things that you might want. So yeah, that's sort of like my basic food introduction. And I hope that through this alcoholic beverages thing, you'll see like some other cool stuff that you can do with food. I'm not seeing any questions specifically about that. So I have a question. Is there a way to enter your health data so that you can perform optimal food consumption computations? So I don't think we have calculators necessarily that work with this like Wolfram language stuff that we have set up quite yet. But you could totally code that in Wolfram language, I think pretty easily. If you come with sort of like, here's what you would have to find a source that has sort of like, here's what the recommended intake is for sort of my age group, my like weight and stuff like that. And then you could calculate this based on sort of like the calorie content of this. So you could potentially put in sort of like what you ate in a day, get using entity instances, get sort of like the exact amount of calories out for each thing, or the exact amount of protein or whatever you're looking for, and then compute that for yourself. So yeah, and I think we definitely like we have a lot more room to grow with food. So if that's something that people are interested in, is having these types of calculators, we can totally develop that too. And I think that would be something really cool to do with this really, I would say, like huge data set. Is there an API for compatibility between health data apps and a database in the Wolfram language? Not that I know of right now, but like I said, you could totally use that. You could use the Wolfram language to code that for yourself. And I would totally encourage everyone to try that out, just because I know we have really good support for different ways of like querying the Wolfram language database. But yeah, like I said, we're trying to grow at every moment. So potentially that could come in the future. Someone says, how about I input all the food items I have in my fridge? You list out all the recipes that can be produced. So yeah, we can't do that quite yet. We don't have a lot of recipe data quite yet, although we do have plans to work with that in the future. I know we have kind of like some data on like cooking times and like recommended cooking times for certain foods. So how long would you boil an egg type thing. So we have sort of like the bare bones skeleton for what you could eventually build into this type of recipe thing. But yeah, I think this is kind of like the holy grail of using computation for food, is like, I don't know what to make, and here's all the things that I have, and here's when they're going to go bad. And what do I make for dinner tonight? To optimize everything. So yeah, I think that would be super cool. And it's definitely something that I think falls under the umbrella of sort of like computational food. So I would definitely be interested to try to implement that in the future. Yeah. Okay, that's all the questions I have right now, but I will continue on with my alcoholic beverages thing. So this is kind of, I already really explained what this section is talking about, but essentially like when you use an implicit food, we do kind of like an averaging or sometimes like a median of all of the data that's included with the foods that live underneath this big sort of like yellow box. And so you can either do that manually by getting the entity list for the food, which is what I did up here, just to sort of show you that what the foods are that live inside of this refried beans box. And then you can get sort of like the median of them. But we also can do that just for you automatically. So if you put an implicit food into entity value at any point, what you're going to get out is this value. So, I mean, this is exactly the same operation, a little bit different here. So yeah, I think that's really nice. You don't have to go through any of this computational stuff unless you wanted to specifically choose what foods go into it, which is totally possible if you're interested in that. And then another thing that I think is cool about this alcoholic beverages data is that we have the alcohol content. So here's what I was talking about earlier about the entity instances. You can get sort of like an absolute value out. So you can see that in 5 fluid ounces, which I think we did like the serving, the recommended serving of wine is 5 fluid ounces. So you can say how much alcohol is in that, how much alcohol is in a pint of beer, and kind of compare that, which I think is really cool. And then another thing that I think is cool is that you can also do computation with these values. So you can get sort of like a relative alcohol content. You can multiply that by however much of the alcohol that you're using. So here I did this kind of demo of how you would calculate how much total sort of alcohol is in a cocktail. So here, if you have like a whiskey sour, which the only alcohol in a whiskey sour traditionally is whiskey. And so if you said like for my whiskey sour, I have 2 fluid ounces of whiskey, how much alcohol is in that? That's kind of straightforward. But once you start to get more complicated and start to make drinks that have multiple different ingredients, I think it's really useful to be able to say like, how much am I actually drinking at the end of the day when I make this cocktail? Which I think is really interesting because I think a lot of people, I mean, myself included, we kind of just eyeball it and say like, oh, this many cocktails, but it can really vary depending on what you put in there. I know there's also sort of a trend right now of like low alcohol by volume cocktails, just sort of like as this trendy new thing of trying to design cocktails that don't have that much alcohol in them. So this would be another cool tool to be able to do that, where you're saying like, what alcohols can I use in what proportions to actually get sort of like a low ABV cocktail to sip on. Cool. No questions on that stuff. Pretty straightforward. So this is just another section where I talk about how you can get the calories out and show some cute little visualizations that you can make out of that. So this is also making use of that that entity list functionality where you get every single wine that's tagged as like red wine or white wine. And you can sort of plot the distribution of that, which I think is super interesting. So while you can get like an averaged out value from an implicit food, if you're interested in sort of like the distribution of what the nutrition looks like for a whole group, you can make your implicit food as specific or as general as you want, and get out sort of like the distribution that you want, which I think is really cool. Something else that we added with the alcoholic beverages data is we tried to get, in every case where we could find it, the like country of origin for each alcohol. So we made this cool little geo bubble chart showing sort of like where the whiskeys that we have at least are produced in the world, which I think is pretty cool. So you have quite the representation in like Scotland, Ireland. There's a lot of like American whiskeys being produced as well, as you can see. And then I think like Japanese whiskey too is something that's getting more and more popular recently. So yeah, I know like some Japanese whiskey is super hard to find and so has become like really expensive and really rare. So so it's cool that that's represented here as well in our data. I'm sure that we're missing stuff, but this is sort of like what our basic distribution is, which I thought was pretty cool. And again, that's making use of the entity list type thing where you can use that entity list function to get the entities out of a yellow box like this, or you can use the property entities, which will give you that as well. And then you can kind of do some distribution work from there. Okay, this next section is kind of like our demo of what you can do sort of like with machine learning. So with alcohols, I know in a lot of cases, the alcohol by volume does not really define an alcohol, but we noticed that between beer and wine, alcohol content can sort of give you an idea of whether or not it is a beer or a wine. So if you just had sort of a big set of just like ABV values and you didn't really know what they were for whatever reason, you could pretty reliably tell what they were just based on the alcohol content, which I thought was pretty cool. And this can obviously be sort of like, this was sort of a very basic touching upon this topic, but like if you wanted to use like carbohydrate content or something like that, I know beer has a lot higher carb content than wine, for example. So I'm sure that would also be a really cool thing to try. So I think, like I said, there's so many properties in food that you can make any number of versions of this type of machine learning example. But here we use alcohol content. And yeah, so we trained this little classifier function using our classify built-in function in the Wolfram language, which I think works really well if you give it sort of like the values that you're trying to go off of. So we trained it on a subset of the data that we had, and then we saved a little bit of that data to see like how it did on new things that the classifier hadn't seen before. And I think it did a pretty good job. This is our results here. So as you can see, like it got that these were beers. Think I think it's harder to tell based on the name of a wine, but I think this is wine. This is definitely wine. I think that's probably wine. So I think it did a pretty good job. And I think like with all the different properties that we have in food, I would be interested to see like what properties actually do a good job at defining sort of like what an alcohol is in terms of food type, or what properties do a really bad job and are not a good way to tell the difference between these things. Another cool thing is that we have flavors as well added to this data. So especially in vodka, I think there's quite the variety of different flavored vodkas. So we have that data in there as part of the like attributes that we use for these implicit foods. So I think some of the ones that we saw before is like variety. Let me see. Yeah, variety. Just variety. Preparation for refried beans. So we have like, I think probably over 50 different types of attributes that you can use for your implicit foods. And one of those is flavor. So in alcohol, I think vodka is probably the best thing to look at when you're looking at fit flavors. So that's what we chose. And we decided to make this little manipulate that allows you to sort of explore what types of alcohols have what types of flavors. So you can pick sort of like a flavor that we have here. So maybe I'll choose coffee, which seems a little wacky. And so based on this manipulate that we built, it replaces sort of like the flavor in this implicit food. This is sort of the skeleton of what an implicit food looks like underneath that yellow box. So if I were to put like the food flavor, coffee, and evaluate that, you get this like pretty box out. But this is what it looks like under the hood. So we just sort of said like if you put something into this slot here, whatever flavor that you're looking for, what's the food that comes out, which is this, what are the food types that are associated with this food? So another thing we have that I haven't gone over yet is these food type groups, which are sort of like groups of food types, which are kind of like the base for a lot of parses. So for example, in this vodka example, food type vodka is sort of like the base of the parse. But you can also use a food type group. So here it's saying like anything that has a food type that's within this alcoholic beverages group that has the flavor coffee. And so we can explore also sort of what those food types are. So a lot of the food types that are flavored like coffee are like liqueurs and whiskeys. So no vodkas in that one. But when you go over to something like fruit, you get a lot of things that are flavored, like vodka, obviously grapefruit liqueur. Beer is a wacky one. I don't think I've seen like a grapefruit flavored beer. That sounds kind of interesting. And then here we have sort of like a computation of all of the averaged out for all of the foods that live inside of this yellow box. So that's just like the calories per gram in that. So like I said, you can make this as general or as specific as you want. I'm pretty sure that if you wanted to even get rid of the like food type for that, you could. Let's see. So we can just take out this condition here inside of this implicit food and get something that doesn't really make a lot of sense. But if you just wanted every single food that we have that's flavored like grapefruit, you could get that. I may not print out all of those because it will probably take forever, but I can see how many we have. Please capitalize. Okay. Wow. 0. Let's see. Let's see if I can fix this on the fly. What's happening here? It could be that it just doesn't like when you don't give it a food type. Oh. That's super interesting. Cool. Well, well, there you go. Maybe it just didn't like that I said no added food types. So maybe let's see the length of that. I'm super glad that it didn't take forever to load, even though I printed it out anyway after I said I wouldn't. All right, 77 things in our database that are flavored by late grapefruit. I think that's pretty cool. And we can replace this with any number of food flavors. I think, let me see if this works too. Entity value, food flavor. And if we just ask for all the entities that are in there, we can also try to get the length of that so that we don't get overdone. So that's 367 different flavors that we have. Let me try to. Chocolate chip cookie dough. That sounds cool. That's probably some ice cream, so. And then, yeah, so there's plenty of things you can do. I could go down this like rabbit hole of like exploring food for hours. But yeah, so I think that's pretty cool. And like I said, like this new alcoholic beverages data, I think a lot of the things that are flavored have their flavor information in there. So there's plenty of stuff that you can do with that. And then we use that kind of flavor data to do some cool visualizations as well. And I think, as you can see, sort of like fruit is a huge thing that you can flavor alcohols with, but there's also some more obscure stuff, like I said, like coffee and stuff that's a little bit more unexpected. And then, yeah, that's basically it. So I think that's pretty much the content that I wanted to show you guys. And let me make sure I didn't miss anything. Yeah, I think hopefully this food basics can get everyone's foot in the door of kind of like, how do you start working with food and make it not so daunting to actually get into this data, because there's just tons of stuff there. And I would love to see sort of like what people use it for and what people want to use it for and can't currently use it for, so that we can develop that for you guys. Yeah. Okay, I have a question. Is there a way to check which foods can be hybridized with each other? I'm not sure I understand what hybridized means in this context. Maybe in terms of like breeding different varieties of like fruits and vegetables, maybe. So in that case, I think food data is not necessarily what you would use to look at sort of like cultivars and varieties of plants, even if they are producers of food. We have some really good like species data for that type of thing. So I think that's probably where you would go for that kind of information. But I know we have plans for in the future to grab that data and make it sort of play well with food. So like if you were looking at like all of our different limes that you could get from the store, and you could sort of see like what is the most common varietal that those come from, and sort of like where, if it's produced in this part of the country or in this part of the world, probably where sort of like what variety of lime tree is it from. So I hope lime comes from a tree. I think so. So yeah, so I think that's a really good question. And I think we have plans to make sort of like everything play well together in the future. Because I think that would be really cool to say sort of like, I want to eat these types of fruits, and what can I do in terms of like cultivating that fruit? Yeah. Doesn't look like I have any more questions. I have a comment that this project seems like a lot of fun, and I agree. Food is super fun. I love developing food, and I love playing with food. Like I said, I can totally go down like the rabbit hole of exploring this stuff until sort of like I look up from my desk and it's dark outside and I'm like, whoa. So yeah. And then another thing I want to show you guys is that I would encourage people to look at sort of like the documentation for food entities and food type entities, which like I said is sort of like the base for a lot of these like implicit foods, because we have tons of them, and I think that there's a lot that we can do with that. So yeah, hopefully I would love to see other people's ideas for projects on this stuff, because I think sort of like I'm limited by like my imagination, but I've seen some people do really cool stuff with this food data, and it's super huge and it's super thorough. So there's tons of stuff that we can do with it. And I would love to get sort of like a dialogue going with people who are interested in this stuff in terms of like what they would like to see us do, what is possible to do in the Wolfram language, and what we can make possible to do in the Wolfram language. So yeah. Yeah, well, I think that about does it. So thank you everyone for joining us. If you have questions after the fact, I know we're going to be posting a recording of this video, and then you can comment on the blog post that inspired this live stream. And then I think we'll also be sending out sort of like the notebook that I was working on today, so that if you guys want to see sort of like some of the little stuff that I added, you're welcome to look at that as well. And please send in comments, questions, concerns. Yeah. All right. Thanks, everyone.